So what I wanted to do today is I wanted to go over those 3 questions that I had given you yesterday. Hopefully I heard some of you trying question 6. I heard some of you trying question 8. I heard some of you trying question 10, which is awesome. So I want to do each one of these questions again. And I want to work through them and see what sort of headway we can make on those questions. And if you have any questions at all, just interrupt me at any point and just be like, I don't get it, Mr. Nickel. Can you explain that again, please? I don't understand what you just did. I just want to make sure that everyone's on the same page. Stoich is tough, and it's miserable trying to teach it through online learning, but it is what it is. This is where we're at. So hope you guys are all doing okay. We're going to work through this first question here, and I actually want to retype it out just so we have it. Okay. So we're going to do question 6, which says 50.0 grams of calcium carbon. Oh, you get to see how terrible I am at typing now. Calcium carbonate was added.
It's pretty small. Is it possible that you could make the writing bigger?
Yep, I am just doing that.
Or zooming.
Okay, cool.
Yeah. Let's make this. How's that? Is that readable?
Yeah.
Okay, deadly. Okay, so this was the question that was asked. It says 50 grams of calcium carbonate was added to excess phosphoric acid. What mass of calcium phosphate was formed? So what I'm also going to do is I'm just going to write out the steps that we should take in order to answering this question. So the first step before anything else that you would do is write a balanced chemical reaction. So that's the first step, and honestly, this step will probably take quite a long time for some of you until we get more and more used to doing these balanced chemical reactions. So the first thing that I know, I would read through this question again and try to figure out, okay, what are the products and what are the reactants? So reading through this question, I see I have 50 grams of calcium carbonate, and I see that's being added to phosphoric acid. So right away, when I see the wording of grams of calcium carbonate is added to phosphoric acid, my guess would be those are both reactants. So I'm actually going to write a word equation first here, just so I can keep track. How's that writing? Is that large enough and thick enough for you guys to see?
Yeah, sure.
Okay. So I'm going to write what I think both of the reactants are based on this word equation. And then what I'll do later is I'll convert these into the actual chemical formulas, and then we'll swap and drop and do all the balancing and everything else. Okay, so first, this is what I think the reactants are based on calcium carbonate is being added to an excess of phosphoric acid. And then the next sentence says what mass of calcium phosphate was formed. That sucked. Let's try that again. So what mass of calcium phosphate was formed? And I would look at this and say, I'm guessing that this is probably a double replacement reaction because calcium carbonate has 2 different parts. And then I would also know that phosphoric acid would probably be made of a phosphorus or a phosphate. And then the acid would tell me that it'd be made of a hydrogen. So I'm guessing that this type of reaction would be double replacement. I don't know what the other product would be. I was told what one of them are, but I don't actually know what the other product would be. So the only way I can figure that out is if I start writing out the chemical formulas. So we're going to do that. And I'm going to write these out in lots of steps so that you can see this. So calcium has a 2+ charge. Carbonate, if we go to our table of ions here, carbonate is right here. It has a -2 charge. So it's CO3 -2. So we'll go back to this slide here. I know calcium carbonate is CO3 with the 2-. Phosphoric acid, I would probably go to my naming chart and say if I ate it, I know that it's icky. And so I'd go back here and I'd look for something that looks like phosphate. And I can see that phosphate is right here. It's PO4 with a 3 negative charge. And because it's an acid, the other thing that I would know is I would know that this is going to start with a hydrogen. And then I know that it's PO4 3 minus. So based on my data table again, I would know that hydrogen, which is on the left somewhere here, hydrogen here has a positive 1 charge. Positive 1 charge. Okay. So then I know that one of the products is calcium phosphate. Well, I already have all the charges written out, so I can just copy these from the left-hand side. I'm copying these from the reactant side and bringing them over to the product side where I have calcium phosphate. That's one of my products. The other product we didn't know. But what you can see right now is that we have a hydrogen with a plus sign here and a calcium with a plus sign here. So that means that both of those two are the cations. And so if we have a reaction with 2 cations and 2 anions, I would know that, okay, I'm just going to switch my 2 cations, and then that will give me the products for my double replacement reaction. And what we'd end up with then is the calcium would join up with the phosphate, as it did already right here. And then we'd see that the hydrogen is going to join up with the carbonate. So our hydrogen with a plus 1 charge is going to join up with our CO3 with a 2 minus charge. So all I've done right now is I've just written out all of the ions that I have. I haven't actually swapped and dropped anything. That's going to be my next step. And then the step after that is going to be writing out the balanced equation. So this is just writing out the ions. The next step is going to be swapping and dropping. And so what that will look like then is we have a plus 2 and a minus 2. I know that that'll just be CaCO3. We have an HPO4. The H has a plus 1. The phosphate here has a negative 3. So this will become H3PO4. Reaction arrow. With the calcium phosphate, we have a plus 2 and a minus 3. So I would know that the plus 3 would come down here. Now the 2 also needs to then apply to all of the PO4, so that's why I put the brackets around it. That 2 needs to apply to both the phosphate and the oxygen. And then the last step we have here, we have a plus 2, or a minus 2, excuse me, and a plus 1. We'll end up with H2CO3. So that was my swap and drop, and then the next thing that I want to do is balance the actual chemical equation. So within this one step, there's 3 other steps that I'm taking. I'm taking the step of writing out the ions. Many of you can get away with not doing that step. That's probably the one step that most of you could omit. Swapping and dropping, that was putting all of the charges where they need to be in the appropriate compounds, and then balancing the chemical equation. That's the last step that we're going to do here, where we're going to put all of the balancing coefficients out in front of these compounds. Does anyone want to unmute themselves and tell me how to balance this? Not everybody at once now. Calm down. Okay, I guess I'll do it then. So what I would do first is I would look at this compound and I would see that I have a Ca3, so I have 3 calciums over on the right side, and I have 1 calcium on the left. I'm going to ignore my hydrogens and my oxygens for right now just because they will be the most confusing to balance. So I would look at this and say, I've got 3 Cas. I know I need at least 3 of those here then as well. I'm going to treat this carbonate, this CO3, as 1 unit. So rather than saying I have 3 carbons and 9 oxygens, I'm going to say I have just 3 carbonates, or 3 CO3s. Because of that, I would then need to come over here and say, well, I also need 3 CO3s. Okay. The next step to check then would be to look at our PO4s. Again, I'm going to look at this as one unit rather than the phosphate and the oxygens. I'm going to look at it as just the PO4 as one entire unit. And I see that I have 2 of those, so I'm going to try a 2 over here, and we're going to see if we can get this whole thing to balance out. So what I've confirmed so far right now is I know my calciums are balanced. I've got 3 over here and 3 over here. I know that my phosphates are balanced. I have 2 over here, and then if I include this as one whole unit, I have 2 over on the left-hand side. I know my carbonates are balanced. I have 3 over on the right side and 3 on the left side. And then the last thing to check would be the hydrogens. Oops, sorry, that didn't erase what I wanted to. So over on this left-hand side, I have 2 times 3 hydrogens, so 6 total hydrogens. And then on the right side, I have 3 times 2 hydrogens, again for 6 total hydrogens, meaning that this reaction is completely balanced. So we did all of that just for the first step of this solution. Okay. So step number 2 then, once we've written out a balanced chemical equation, what we want to do is start our question with the variable in the question. Oh, start our answer. We're going to start our answer with a variable in the question that has both a number and a unit. Then we are going to convert it into moles. Okay. So what I'm going to do here is, as I'm working through the question, I'm going to highlight my steps. I'm going to explain what I'm doing via my steps in the blue pen. So anytime there's blue, that's not actually part of the question. That's just me explaining, here is what I'm doing. So that when you reflect on this, you can say, okay, I know that blue always means Mr. Nichols just over explaining as he always does. So what we have in the question here is we have 50 grams of calcium carbonate was added to an excess of phosphoric acid. What mass of calcium phosphate was formed? The only thing that we have both a number and unit for is this 50 grams of calcium carbonate. So that must be where I start. So start our answer with the variable with the number in the unit, 50.0 grams of calcium carbonate. So what we want to do then, the next step is we want to convert this into, I don't need that much space. We want to convert this into moles of calcium carbonate. And so to do that, we would need to figure out the molar mass. And we would go visit our lovely periodic table, which is here. We would see that calcium has a mass of 40.08. We would see that carbon has a mass of 12, oxygen has a mass of 16. So I'm going to memorize all 3 of those values and say I know that calcium was 40.08, and there's only one of them. Carbon was 12.01, and then we had 3 oxygens, so we need to do 3 times 16. When you add those numbers together, you should end up getting an answer of 100.09. So this is 100.09 grams of CaCO3 for every 1 mole of CaCO3. So this was the molar mass of CaCO3. The next step that we're going to take then, I'm going to leave some space here. You don't have to, but I'm leaving space so that I can answer this next question. What we've done is we have gotten out of grams of CaCO3, and now the only unit we have left is moles of CaCO3. So I know that on the bottom of this fraction, it must be a mole of CaCO3. So what we want to do in this step here is we want to use the molar ratios to convert between moles of substances. To convert between moles of substances. And to do so, we're going to use our balanced equation. And so what I would do then is I would scroll up here, look at my balanced equation and say, I know that based on this question, there are 3 moles of CaCO3 that are required. What we'll want to do next, the next step that we'll want to take is we will want to go into moles of whatever the question is asking us for. So the question asked us what mass of calcium phosphate was formed. Well, that means that I need to go into moles of Ca3 PO4, I need my brackets, 2. And I can see in this equation, I haven't included a 1 in front of this because that means that I was lazy. So that means there was 1 mole of Ca3PO4 with a little 2. So now what I've done is I've gotten out of moles of CaCO3. I no longer am in moles of CaCO3. Instead, what I'm just left in is moles of Ca3PO4 with a little 2 beside it. So the next step that I would want to take then, is I would want to go where the question is asking. So I'm going to write that in blue down here. Go where the question asks. The question asked us to get out of moles of Ca3PO4 with the 2, and it asked us to find out how many grams of Ca3PO4 2 were present in this reaction. Okay. So what we're going to do here then is we need to calculate again the molar mass of Ca3PO4 2. So I know that calcium was 40.08. Oops, let's try that again. 40.08. And I also know that there are 3 of them. So I'm going to times that by 3. One of the trickiest parts about this question is this PO4 here, figuring out the molar mass of that. And so with the PO4, if we go to our periodic table, phosphorus has a mass of 30.97. So phosphorus has a mass of 30.97. And then the question becomes, how many of them are there? Well, kind of like we talked about earlier, we had said that the little exponent out here is kind of like you're foiling it out. It's kind of like you're foiling this statement where we have 2 phosphorus and 8 oxygen. So we have 30.97 times 2. And I just said we have 8 of the oxygen, which is 16. So this is the molar mass of Ca3PO4 2. And what we find is that this is equal to 310.21. We find that this is 310.21. And so that value is going to come up here because we just figured out how many grams per 1 mole calcium phosphate is worth. So that then becomes all of the stoichiometry that we've done. This first part up here wasn't any of the Stoich. That was just simply writing and balancing equations like we did in the very first unit. And then the second part here, part 2, start with our answer with a variable in the question that has both a number and unit, then convert to moles. That actually is stoichiometry. So we convert to moles, and then the key step that we do is this step here, where we're using our molar ratios, and we're converting between moles of different substances. So what we've done is we've gotten out of moles of Ca3PO4 and into grams of Ca3PO4 with the little 2 beside it. And if we were to plug this into our calculator, it would look like 50 divided by 100.09 divided by 3 times 310.21. And that answer then is going to be equal to 51.66 grams of Ca3PO4 2. And that is our final solution.